Here's your test review. We're going to use this graph to answer these questions underneath. So if the figure is translated 4 units left, what are the coordinates of J? So right now, the coordinates of J are 0, 0. So that's the original point. And if we go 4 units to the left, that's going to affect our x value. So that would be like x minus 4, and our y would stay the same. That's the rule. So I would take my x value, which is 0, and I'm going to subtract 4 from it. So I would get negative 4, and my y is going to stay the same. So that's what J prime is, negative 4, 0. If the figure is translated 2 units left, so that would be x minus 2, and 4 units down, that would be y minus 4, so that's my rule. What are the coordinates of L? So right now, L is 4, 2. So just in case you're wondering, I just got that from right up here on the actual graph. So if I subtract 2 and subtract 4, I'm going to be left with 2, negative 2. So those are my new coordinates. If the figure is rotated 90 degrees clockwise about the origin, so some of you are a little bit concerned because it says about the origin. That just means we're going to go around the origin, which is the way we've done it every single time. So 90 degrees clockwise. The rule, if we look on our sheet, if you go 90 degrees clockwise, it's going to be y negative x. And we're looking at M. So the original coordinates of M are 1, 2. So if I do y, and then the opposite of x would be negative 1. So those are my new coordinates. Number 4 says, write an algebraic expression to represent the rotation. Well, it turns out we basically just did that with our rule, so it's y negative x. If the figure is reflected over the x-axis, what's the coordinates of k? Well, if we reflect over the x-axis, our x's are going to stay the same, and our y's are going to change to the opposite sign. So k right now is 3, 0. So our x's would stay the same and our y is going to change signs, but actually it turns out that that's going to stay a 0 because you can't have a negative 0. And it makes sense on this graph right here because right here is 3, 0, and if you reflect across the x-axis, it's going to stay exactly where it is. This one says triangle XYZ has those vertices, and we want to know what are going to be the new coordinates after a translation of 3 units to the right and 1 unit up. So 3 to the right is going to be x plus 3, and 1 unit up is y plus 1. So for each value, we're going to add 3 to the x and then add 1 to the y. So negative 4 plus 3 is negative 1. And then we do 3 plus 1 is 4. Then we're going to do the next one. Negative 1 plus 3 is 2. And 2 plus 1 is 3. Negative 2 plus 3 is 1. And then 0 plus 1 is 1. So those are our new coordinates. Next one, this has this vertice. What are the coordinates of point A after a reflection across the y-axis? So our rule for if you go across the y-axis is negative x, y. That was like the weirdest x I've ever written. Sorry about that. There you go. So looking at point A, originally it's negative 1, 3. So if I do the opposite of what's there, the opposite of negative 1 is positive 1, and my y stays the same. So this would be my new point. I'm going to use this graph for the next couple questions, which it's going to go on to the next page, so I'll have to kind of flip back. So it says graph and label the image of triangle YZW. So first of all, I'm going to put my points for y. Y is a negative 4, 2, and I just got that right here off the graph. Z is 4, 2. I got that right here. and W is 0, -4. So those are my original points. Then it says, after a translation of 2 right and 1 down. So that would be x plus 2, because if I go right, it's positive 2, and then 1 down, so I'm going to minus 1. So there's my rule. So I would add 2, subtract 1 to each. So -4 plus 2 is going to be -2. 2 minus 1 is 1. Then 4 plus 2 is 6. 2 minus 1 is 1. And 0 plus 2 is 2. And -4 minus 1 is -5. So those are our new points. This next one is still talking about number 8, which basically says write the algebraic expression. Well, I just did that on the page before because we said it was 2 units right and 1 unit down. So if we go to the right, that's adding. So adding 2. And then 1 unit down, that's subtracting 1. So it would be x plus 2, y minus 1. For 10, it says graph and label the image of YZW after a reflection across the y-axis. So this is the y-axis. My original points were W was this, Y is this, and Z is 4, 2. If I reflect across the y-axis, the rule is that we would do -x, y. This is our rule. So I'm going to take my x value and I would change to the opposite sign. But it's a 0, so it's going to stay a 0. So this one I'm going to change to the opposite sign, so it's going to be a +4. This one is a +4, so I'm going to change to the opposite sign. So my y is 4, 2, my z is -4, 2, and my w is 0, -4. So then I could plot those. So y would be, I would go over 4 and up 2. Then z would be, I'd go -4 and up 2. And then w would be 0 and then -4. So there we go. Next one. What are the coordinates of this if we took the triangle we just created in number 10 and we went 3 units down? So I'm going to use, these are my original points now. I'm going to go 3 units down, so that means my y is going to subtract 3. So my x's are going to stay the same, and then I have to subtract 3 from each y, so it would be -1, -1, and -7. Next one, we have a triangle. It tells me the vertices. This one has multiple transformations. It's reflected over the x, so the first thing is reflect over the x, and then we're going to translate. So let's talk about our rule if we reflect over the x. Our rule would be x -y. Then, if we translate 2 units left, it would be x minus 2y. So let's talk about this. So our original points, A, 3, 2, B, -2, 3, and C, 1, -3. So our first one was x -y. So we leave the x and we make the y the opposite sign. Okay, but we're not done, because then we have to do this x minus 2. So we're going to subtract 2 from each x and leave the y alone. And then these are my new points. So 1, -2, -4, -3, -1, 3. So there's that. Quadrilateral KLMN has those vertices. This is another one that's got some multiple things. So the first thing we're going to do, it's rotated 90 degrees clockwise. Then the second thing is that it's translated 1 unit down. So first, if it's 90 degrees clockwise, my rule is y negative x. Then, if it's 1 unit down, my x's will stay the same, but my y is going to subtract 1. So my original points are k. I'm just going to rewrite L, because I just find it useful to be able to like actually work with it right underneath. So I'm going to do this first thing, y goes first, but it stays what it is, and then negative x, so this was a positive 2, so it's going to change to be a negative 2. Then I'm going to use the same rule, so negative 2, negative 5, negative 5, negative 7, and then negative 4, negative 4. But I'm not done, so now I have to do this second part. My x stays the same. My y, I'm going to subtract 1 from it. So those are my new points. My first point is negative 1, negative 3, then negative 2, negative 6, negative 5, negative 8, and negative 4, negative 5. Sorry, that's horribly ugly, but these are the points right over here. Fred rotates the rectangle 180 degrees about the origin. So the first thing we do is rotate 180 degrees. Then reflects the triangle over the x-axis. And then translates the rectangle up 2 units and left 5 units. So let's talk about our rules. If we go 180 degrees, the first thing we're going to do is our rule is negative x, negative y. Then if we have to reflect over the x-axis, then it would be x negative y. And then the last thing, if I go 2 units up and 5 units left, it would be x minus 5 because it's 5 units left, and y plus 2 because it's 2 units up. This is going to be tricky for some people because normally it tells you left or right first and then up or down because x comes first. But it doesn't have to go in that order. So it says we only have to worry about point x, so this point right here. So let's figure out what point x is right now. Point x is a little bit confusing because this is counting by 2's every time on both axes. So this point x is really at negative 5 because it's halfway in between the 4 and the 6. You see right here, so like here's 4, here's 6, and x is halfway in between. That's super blurry, but you got it. And then our y value is 2. So our x originally is going to be negative 5, negative 2. So now our first thing we have to do is do the opposite of x. So we're going to use this rule right here. So opposite of x, which is that, and the opposite of y. So we did the first, the rotation. Then we have to do the second part. So we have to do x negative y. So we're going to leave this x the same, and we're going to change this 2 to be negative 2 because it's the opposite. So that's, first one's done, second one's done. Now we're on to this last one. So we have to subtract 5 from the x, which gives us 0, and we have to add 2 to the y, which gives us 0. So our final point is 0, 0, and we look and we're so happy because it's an answer choice. So we know we did it pretty well. This one is a typo because we changed our mind about the picture we were going to use. So this should say triangle ABC was dilated to create triangle A prime B prime C prime. So it wants to know what's the scale factor. Well, luckily they actually gave us these points, so we don't even have to find them ourselves. They gave us the original and the new. How do I know these are the original and these are the new? Well, because this has the prime. So remember, we know that the prime is always the new. So we know that the original times the scale factor is what gives us the new points. In my class, we say original as OG, but anywho. So the original point, so let's look at this first one. The original point was -2, -2. Then we multiplied by some number, and we got this new point, which was -4, -4. So by looking at it, you can see that we multiplied by 2 to get -4, so that means our scale factor is 2. If it's not so easy to see, then we could take this original equation we had, the original, that's a horrible O, the original equation times scale factor equals new. And if we're looking for the scale factor, I could move the original to the other side by dividing by the original. Remember in algebra how like these are multiplying, so the opposite of multiply is divide, and that's how I can move it. And these would cancel, so I get scale factor equals new over original. So to find the scale factor, I would take my new point, which we'll use right here, -4, and divide by my original point, which was -2, and if I divide it, I get 2, so that's another way to find the scale factor. So now that I know the scale factor, I have to use my bubble sheet. So this is kind of new compared to what you had last year. So it's got the decimal for you. So you know 2 is like the whole number 2.0, right? So 2 would go in front of the decimal. If you put the 2 way back here and you leave the rest of this blank, you're going to get it wrong because that would be like 0.02. That's what that would mean. So if you want to, you could put zeros back here, but this actually is perfect how it is. And something I would prefer you do is, do you see on this far left side how it has a positive and a negative? We know it's positive, so I would go ahead and fill in my positive. If we're taking the star, if you leave this part blank, it will assume positive, but I would prefer you go ahead and always bowl in the positive. Okay, 16. Rectangle RCTG is dilated by a scale factor of 1/5 to create rectangle R prime C prime T prime G prime. Which statement is not true? Well, I always need to draw pictures in ones like this, so I'm going to draw myself a rectangle RCTG. And I know it's being dilated by a scale factor of 1/5. So, basically I know it has to get smaller, because if the scale factor is less than 1, then it's going to get smaller. So my new triangle, or not triangle, rectangle would look like this. Okay, it might actually be smaller than that, but you get the picture. So the question, or the statements, I'm going to go ahead and read them. They're talking about the perimeter, how they're related, and the area, how they're related. Okay, so something that we just haven't really talked about, perimeter is just going to have the same scale factor as whatever the side length scale factor is, but area, the scale factor would square. So the way I remember that is like, if you find the perimeter of a shape that's in like centimeters, the perimeter would still be centimeters. But if you find the area of that shape, it would be centimeters squared. So that squared reminds me that the scale factor would also be squared. But something you could do, if that's kind of confusing to you, is just use actual numbers and use the scale factor and see what happens to the perimeter and area. So I'm just going to make these numbers up, and I'm going to use the scale factor of 1/5. See how I conveniently made them all divisible by 5? Because if I use a scale factor of 1/5, I'm basically dividing all the sides by 5. So this would be 2, 1, 2, and 1. So the perimeter of this original shape would be 30, and the area of this shape would be 50. The perimeter of my new shape would be 6, and my area would be 2. So now I can kind of use those as an example of what's happening. So this says the perimeter of rectangle RCTG, so it's talking about this perimeter, is 5 times the perimeter of this one. Well, if I did 6 times 5, would it give me 30? Yeah, it does. So that statement, that's true, because this perimeter is 5 times the amount of this one. So 6 times 5 is 30, so yes. The area of this one is 25 times the area of this one. So if I do 2 times 25, I get 50. Well, that is what my area was, so that's true. But we're looking for which one is not true. So now it says the area of rectangle, the prime one, the area is 1/5 times the area of the rectangle. So if I replace this, it would say 2 is 1/5 of 50. So if I did 1/5 times 50, that would give me 10. And 10 is not equal to 2, so this one is not true. Then I'm going to check the last one. 2 is 1/25 times 50. If I multiply this out, it would give me 2, and 2 is equal to 2, so that's true. So the one that's not true is C, so my answer for that one would be C. Okay, last part, we're going to choose the word from the word bank that best matches the definition. So we gave you some extra words up there just to throw you off. A change in position, shape, size, or orientation, that's the big umbrella term. That is a transformation. So that covers translations, shape, dilations, and orientation would be rotations and reflections. Transformation that moves points the same distance in the same direction. So if it moves it, it's a translation. If it creates a mirror image, that's a reflection. And if it turns it, it's a rotation. And the last one, if it makes it larger or smaller by a scale factor, that's a dilation. All right, that's it. So if you have any questions, see us before or after school. Otherwise, good luck studying, and we'll see you in class.